Okay, how to memorize the unit circle. So the first thing that we want to do in the unit circle is we want to recognize that the whole thing is 360 degrees, right? So right here, I've decided to divide it into slices, right? So if we look at these yellow slices, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So we have 12 slices. Like think about dividing it into 12 slices of pizza. So if the whole pizza is 360 degrees, then that means each slice is 30 degrees, right? So we could do just real quick if you wanted to see it. 360 divided by 12 equals 30 degrees per slice. So that's what we're going to start with the degrees. So we start here. This is 0. We start at 3 o'clock. We have 30 degrees. We're only doing the yellow line. 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 300 degrees, and 330 degrees, and then finally back to 360 degrees, right? So that means each one you're adding 30 degrees. So next we want to do the radians. So the radians, right, we get that from the circumference, right? Circumference is 2 pi r. That's the formula for circumference. And here we have a unit circle. So r is equal to 1, right? So our circumference is 2 pi times 1, which is just 2 pi. So our whole, this is like the crust of the pizza, right? So the entire crust is 2 pi. So we want to think of what each slice would be. So if the entire crust is 2 pi, then each slice is 2 pi divided by 12. And we can keep pi, but we want to simplify this. So they're both divisible by 2, so we can write that as pi over 6. So each crust is divisible by 12. So we're going to start here at 0 radians. Then we go up one slice. So we go pi over 6. So 1 pi over 6. And then we add another slice, right? So let's look at the math here, right? We have pi over 6 plus pi over 6. Remember when we're adding fractions, we keep, as long as the denominator is the same, we can just add the top. So this is 1 pi plus 1 pi is equal to 2 pi over 6. Right? So this one is 2 pi over 6. And then we add another one, 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6. So, it's okay. So there's 2 pi over 6, so we get all the way around, and you notice some of these you can reduce, right? So 12 pi over 6, for example, we have 12 pi over 6. Then we can reduce that. Both of them are divisible by 6, so we get 2 pi. 2 pi over 1, or just 2 pi. So a lot of these that we can reduce, right? 2 pi over 6 turns into pi over 3. 3 pi over 6 turns into pi over 2. 4 pi over 6 turns into 2 pi over 3. 5 pi over 6 you can't reduce. 6 pi over 6 just turns to pi. 8 pi over 6 turns to 4 pi over 3. 9 pi over 6, they're both divisible by 3, so we get 3 pi over 2. This becomes 5 pi over 3. And then 11 pi over 6, you can't simplify. And then this becomes 2 pi, right? We already knew that. The whole entire thing was 2 pi. So this is how we do radians. Remember, we're only looking at our 30 degrees slices, right? All right, and then finally, we have coordinates. So I'm going to take this corner right here. So let's look right here, right? We're here on the circle. So this is our coordinate plane. This is 0, 0, right? And we have this triangle. This is 1. This whole thing is 1 because our radius of our circle is 1, right? And then this right here, this theta, is 30 degrees because we're looking at the 30-degree slice. So I'm going to zoom in, I guess. Okay, so when we have a 30, 60, 90 triangle, we have the thing that's opposite of the hypotenuse is half. So we have half, and then root 3 over 2, right? When we have our 30, 60, 90 triangle, we have x, 2x, x root 3. So if this is equal to 1, this is half of that, and then this is root 3 times whatever x was. 1/2 times root 3 equals root 3 over 2. So right here, we have our x is root 3 over 2, and then our y is 1/2. So we're going over root 3 over 2 and then up, right? If we were to graph this on a coordinate plane, this is x, y. So something that you need to know about the 30, 60 degree slices is that our coordinates are always going to be 1/2 and root 3 over 2, except for at these main ones, right? At our 0, 90, 180, and 270. Okay, so let's start with our coordinates here. So right here, right, if this is 0, 0, then this is 1, 0, right? And so then we go up. So we're going over root 3 over 2, and then we're going up in our y direction 1/2. Remember our 4 quadrants, right? We have positive, positive, negative, positive, negative, negative, and positive, negative, right? So here we are going over x 1/2, and then we're going up y root 3 over 2. Right here at 90 degrees, remember this is 0, 0, so this is 0, 1. It's going to the left or right 0, but it's going up y 1. Over here, we have negative 1/2 root 3 over 2, right? Because we have a negative x, and then we're going up, still positive y. And then here, we have negative root 3 over 2, and then 1/2. So we're going negative x root 3 over 2, and then we're going up 1/2. So right, you notice all these coordinates in between is just a mix of 1/2 and root 3 over 2. And then you almost want to call them corners, but they're not corners because they're on the circle, right? These sort of north, south, east, west points, they are either 0 or 1 or negative 1, right? So this one is negative 1, 0, right? We went negative 1, 0. So here we go over to the left, negative root 3 over 2, and then we go down, negative 1/2. This is negative 1/2, negative root 3 over 2. This one, right, if this is 0, 0 right here, then this is 0, negative 1. Then here we have 1/2, and then negative root 3 over 2, root 3 over 2, and negative 1/2. So we have the coordinates, the radians, and the degrees for everything for our 30-degree slices, right? So now I'm going to look at our 45-degree slices, right? So we're going to ignore these other lines. We're only caring about our 45-degree slices. So this is a different type of pizza, right? This is an 8-slice pizza, right? This group of people are hungrier. So we have 360 degrees total in our circle still, but we have 8 slices now instead of 12. So if we do 360 divided by 8, we get each slice is 45 degrees. And you can sort of see it, right? This looks like, you know what a 90-degree angle is, and this is half of that. So each slice is 45 degrees. So let's start with our degrees. We start at 0, then we go 45. 45 plus 45 is 90. 90 plus 45 is 135. We should know that this is 180. A straight line is 180. 180 plus 45 is 225. Then we have 270. And then 270 plus 45 is 315. And then 315 plus 45 is back at 360. So that's how we can tell if we're doing it right, because we know that this is 360 degrees. So we start at 0, we go all the way around back to 360. So let's do a similar thing for the radians, right? The radians, the whole thing again is 2 pi. But we want 2 pi over 8 to figure out the crust, right? This is our crust, the crust of each slice of pizza. So we can reduce this. They're both divisible by 2, so we get pi over 4. So each crust is pi over 4. So let's start here with 0. Then we have pi over 4, 2 pi over 4, right? Because we have 1 pi over 4 plus another pi over 4 is 2 pi over 4, plus another pi over 4 is 3 pi over 4, another pi over 4, 4 pi over 4. We get another slice of pizza, 5 pi over 4. Another slice of pizza, 6 pi over 4. 7 pi over 4. And then we're back here at 8 pi over 4. So similarly, a lot of these will reduce, right? So this one will turn into pi over 2 because they're both divisible by 2. This one turns into just pi. It's 4 over 4. This one turns into 3 pi over 2. And then 8 pi over 2 turns to 2 pi. So our coordinates for the 45, 45 degree triangles are even easier, right? So if we had a 45, 45, 90 degree special triangle, right? This is 45, 45. Remember, this is x, x, x root 2. So if x root 2, if this is 1, so to get from this side to this side, we multiply by root 2. So to get from this side back this way, we need to divide by root 2. So to get here, we do 1 divided by root 2. But we don't want to have this root sign on the bottom, so we're going to multiply root 2 over root 2. So we get root 2 over 2, right? Root 2 over 2. So if we're looking right here, we see this triangle, right? Right here at the center, we have 0, 0. And then we go over to the x amount, root 2 over 2, and then we go up the same amount, root 2 over 2. So the 45, 45 degree coordinates are pretty simple. It's just root 2 over 2 and root 2 over 2, and then you just have to change the signs based on the quadrant, right? Like which quadrant are we in? Are we in 1, 2, 3, or 4? So let's start back here at 0. So we have 1, 0, root 2 over 2. So these are both positive. Then we have 0, 1. Then we have a negative and a positive. So negative root 2, 2, root 2, 2. Here we have negative 1, 0. Because if this is 0, 0, we went to the left 1. So we went in the negative direction. Here they're both negative. Root 2 over 2, right? We went negative, we went over to the left in the negative direction, root 2 over 2, and then we went down in the negative direction, root 2 over 2. Here we have 0, negative 1. Here we have root 2 over 2, and then a negative, we're in the negative y, and that's it. So these are our 45 degree slices. So now we want to put it together, right? We want to be able to read it together. So this is where a lot of people get tripped up, is when you put it together. So let's zoom out a little bit. If you look and see, some of these are the same, right? This is the one where I combined it, and the green is where it overlaps. So it overlaps here at these, north, south, east, west poles, or like 3 o'clock, 12 o'clock, 9 o'clock, 6 o'clock, right? So if we look, let's take a look at these, right? I'll use my green highlighter because yellow plus blue is green. So look, we have 2 pi over 4 that turns into pi over 2. And then we have 3 pi over 6, which also turns into pi over 2. So they're both pi over 2, right? If we look here, they're both pi. That's a pi, and this is a pi. If we look down here, this is 3 pi over 2, and then this is 3 pi over 2. And then here, they're both 2 pi. They both simplify to 2 pi. So when you combine them together, you just want to make sure that you don't skip or double count. So I'm going to go through and show you how I do the unit circle. So I'm going to have this combined version. So first I'm going to start with my degrees. So I go 0, 30, 45, 60, 90, 120, 135, 150, 180, 210. So actually I'm just going to add 30 each time. 240, 2. So I'm going to skip the blues. 300, 330, and then 360. And then I'll just fill in the missing one. So this is 220. So remember, there's 30 in between this, so each one is different by 15. So this is 225, and this is 315. Right? It's right in the middle between our 300 and 330. Then I'm going to do my radians. I'm going to do my 30 degree slices. And I'm just going to go around, and I'm going to count the slices as pi over 6. So I have 0, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. I'm skipping the blues. 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 2 pi. And then I'm going to simplify. So this is pi over 3, pi over 2, 2 pi over 3, pi, 4 pi over 3, 3 pi over 2, 5 pi over 6, and then I'm done simplifying. And then I want to go in and do the blues. So this is pi over 4, 2 pi over 4, but I'm not going to write anything because I already did that. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, not going to write it. 7 pi over 4, I will write it. And then 8 pi over 4, which is 2 pi. So the thing when you're going around and counting is you want to make sure that you don't write these twice, right? Like I already went through with the yellow and wrote down my radians. So when I go back around with the blue, I don't want to do like pi over 4 and then go over here and do 2 pi over 4. I have to remember that 2 pi over 4 is right here. Then I've already done that. And then we just do the coordinates. So I'm going to start with the 4 corners. So we have 1 and 0, 0, 1, negative 1, 0, 0, negative 1. And then I'm going to do the 1/2 and the root 3 over 2 combo. So I just have to think like which one's bigger, right? Root 3 over 2 is bigger than 1/2. The way we can see is this root 3 is bigger than 1. If you think about it, I don't know exactly what off the top of my mind what root 3 is, but I know that root 1 is 1. So root 3 has to be bigger than 1. And we can just do it in our calculator real quick, right? So we have root 3 over 2 is 0.866. And then 1/2 is obviously 0.5. So this one's bigger, right? So I want to look right here. If I'm in my xy coordinate, right? If I'm like, this is positive x, y, negative x, negative y, right? If I'm going positive x and then I'm going up, I'm going more over to the x than I'm going up, right? This is a bigger. I'm going more to the right and then I'm going up, but not as much. So I want my x value to be the bigger one. So that's root 3 over 2, and this is 1/2. And then over here it's the opposite. I'm going over, but I'm going up more than I'm going over. So it's 1/2 root 3 over 2, negative 1/2 root 3 over 2, negative root 3 over 2, 1/2. Right now we're in the quadrant 3 where everything's negative. So negative root 3 over 2, negative 1/2, negative 1/2, negative root 3 over 2. And then over here, quadrant 4, we have a positive x and a negative y. And then we have still positive x and negative y, but the numbers change, right? We went over root 3 over 2, and then we went down 1/2. And then finally, we just have this last one. So we have root 2 over 2. Sometimes you could just write all the numbers and then put the signs at the end. So right now, I'm just going to write all the 2's, the root 2 over 2. And then I'm going to check the signs. This is positive, positive, negative, positive, negative, negative, and then positive, negative. And that's it. We have the whole unit circle. So in the future, what we're going to have to do is I'm going to ask you, I'm going to be like, at pi over 4, what is the x coordinate? And you want to be able to see in your head, or maybe you can write it down on a unit circle for yourself. You want to see, okay, I'm here at pi over 4. My x coordinate is a positive root 2 over 2. So that's the whole point of the unit circle. This is how I learned it. You can just memorize it. You can try and learn the math behind it. We'll obviously go over it in class, but it's really important that you know this for this unit. It'll make everything so much easier. Also, I just like to add, if you don't have a printer, you can still make the unit circle and just like practice on your own, right? So just draw a circle, draw your north, south, east, west, draw a line in the middle for the 45 degrees, and then draw your 30-degree slices on either side, right? And then in your head, you could just do this, right? You could just do 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330. And you can fill it out yourself. You don't need a printout to be able to practice.